Hello, this week we're going to talk about database applications and privacy implications. So first of all, we'll, we'll skip all of this. A database application is the way we store information. It is the device, it is the mechanism we use to store information. It's a software program. And we start out with looking at the Google guys. And why? Because Google created really the use of the internet, which the internet is nothing more than a elaborate composition of servers that are owned by private organizations all over the world that store information, of which you query, you do a Google search to be able to get that information. So Google actually changed the way things were. It was a direction. They went away from trying to embed things in the computer to saying that actually information lives outside of the computer but into a bigger type of environment. So what is a good database? There's a couple of different things. First, it can store large quantities of information, retrieve quickly, reorganize. But a good database nowadays can take multimedia. So it can take objects that are graphics, it can take pictures, it can take text, it can take music, audio. That is the definition of a good database in our day and age. So a database, a collection of information stored in a computer. This is a file cabinet, but if you think of it in those terms, you're very limiting yourself. But let's just start out with that simple process. You have a file cabinet, and in the file cabinet you have files, and you put a label on the file, and you put information related to that file, documents, it might be receipts, whatever it could be, into that file. And you access it by looking at that label. So, for example, we have a record, Michael J. Quinn, and here's some information about him. And all of the information, this Michael J. Quinn, that's his name, copyright, maybe his address, ISBN, those are called fields. They're individual discrete pieces of information. So we'll go on further. A table, what we have now, most of our databases now are table related. We're going to go into SQL in a few minutes, but in the old days, I just want to kind of put things into a perspective. In the old days, there was no database. It was just a long file. So just imagine you just had a long file of information, and you had to read it sequentially to find the information you wanted. So one big problem was, like, you might have customer information, and you would have one phone number for the customer. Well, what if nowadays nobody has one phone number? People might have a work phone number, they have a cell phone number, they may or may not have a home phone number. So, for example, you would have multiple incidents of a particular thing, a phone number. Being able to add information to that long file was horrible, because you had to go into the file, you had to then add a new field in the file that would rearrange where all the data was in that file. You'd have to change all the programs because now the file was a different length. It was a very complicated process. With database, however, we look at each event as a discrete chunk of information, and we can easily change those by adding these discrete pieces of these fields to tables, and we'll go on with that in a minute. Database operations, we can import, we can browse, we can query. So what does this mean? We can import, we can put things into the database, we can browse, we can look through it, we can find information that matches a specific criteria. A query means that we say, find me all literature, for example. Find me all literature where the word feedback is in the title, and the date it's been published is 2010 and greater. Okay. We can sort the information, we can print it, and we can export it to another program. So, for example, I'm able to export information from a file and put it into Excel to be able to do manipulation. Okay, SQL. Everybody's heard of SQL, Structured Query Language. It's a standard language. If you use any kind of SQL Server type of applications. Access, if you use Access, you code in Access, that particular database. They all use a query language, a structured query language, where you say, if, in a data element, if name equals Conrad, then export, okay, or then find address. Smart web searching. Be specific. Use quotes to narrow your search. Use quotes only if you think it's pertinent, and you have to know if the SQL language expects it. Be selective. Triangulate. That means, like, when you get a piece of information, compare it to another piece of information to validate you have the right stuff. Okay, media libraries, personal information managers. Those actually used to be the old Blackberries. Now we use our phones. All right. Geographic information systems. Google Map is the perfect example, and your phone is one. Every time you put on that indicator saying allow the phone to track you, it is accessing this geographic information system to be able to find you. So, for example, you're able to get directions from where you are to a specific location. And web databases uses XML to turn a database into a static page into a database-driven information space. So what does that mean? It just means that you're able to take a static page and collect information, and then can be able to add it to some database that you've created attached to your page. It's not really attached, by the way. It just is. It's connected via some commands. Okay, SQL servers are understood by Access, SQL Server, DB2, Oracle. Oracle's a big one. Oracle's a big one. If you're going to go to a database, Oracle has been the leader forever. Sybase has sort of slipped. MySQL is not as popular either. It's like SQL Server, Microsoft SQL Server, or Oracle. Those are the two that I'd really recommend knowing. There used to be other ones called Database, DBMS2. Oh, here it is. But there are lots of other ones that used to be around. And because there were different types, there used to be the hierarchical, there used to be unnetworked, but now we really are going to object-oriented relational databases. SQL Server is a sub-language that uses high-level, easy-to-understand statements. And SQL Server is like the precursor to natural language. And natural language is when you just say, like I just use when I'm going into Google, I'll just say, find me PowerPoint with automation. How do I automate with PowerPoint? I just put a sentences. That's natural language that actually is able to derive a SQL statement from that. Okay, what is a database management system? It is a software, first of all. A database can manage, a DBMS can manipulate data in a large database. It is a software. It is not a hardware. Data redundancy means if you have the same data in multiple places, danger, Will Robinson. That means data redundancy. The data in multiple places means that the data can get out of sync. Big problem. So if you have an address in too many different places, you have to make sure you would have to update the address in all those different places. Just put the address in one place. Data consistency. All tables must contain the correct information. Well, of course, everybody wants that. Okay, what makes a database relational? This is very important, okay? So tables are related because, for example, here is, if I can look at this carefully, here is a transcript table. And notice how the first thing is they are all related by student ID, okay? Student ID, all right? Now, the student ID, the transcript table, student table, this is the student information. So I would call this like the student, student demographic information. And then here's the class. Okay, so here is the student ID, once again, and it is what we would call the header record, and it will have multiple classes under the header record. All right, so you have to know what is the key to be able to connect records and connect data. All right, so it's very, very important to be able to do this. Okay, databases, they allow for real-time computing. There was a time when everything had to be done, quote, in batch. That meant that it was done all at one time, but to do it in batch, like payroll is a perfect example. You do that in batch. All the payroll records are processed at the same time. The issue becomes that you cannot update those files real time. Once they start to process, they only process them at that one time, and then they won't update them again until the next time or the next night. A lot of financial information that is Old-time COBOL programming that's still out there is all done in batch. Batch is very efficient. Okay, downsizing. Client-server approaches use requests to access data. So we really are moving away from a client-server. A client-server would mean that the client, our computer here, has got a piece of software on it, and that the server has another piece of software where the two kind of meet together. But it requires you to have a piece of client software on each machine. Well, you can see where that could be difficult, because if you had a lot of machines, that means you'd have to load the software on each of the machines. You have to be able to update the software on each of the machines. So what you're going more for now is a web presence, virtual presence on the machine, where you go into a web browser, and the web browser then attaches you to the server, and all the work is actually done on the server. It's not done on the client. So for example, Excel, when you do Excel, it's done on your client, because Excel is loaded on your client. But if you are doing a Google search, you are on somebody's server out there in the internet land doing that search. Okay, so distributed databases spread data across networks. All right, so that's what the internet really is. Data mining, which is a very big area. So if you want to go into big data, you hear the concept of big data. Big data just means big data sets, because now we have access to data from all over many different places. Data mining is actually going into the data, doing queries, getting data out, and trying to connect data to find meaningful relationships and patterns. A data warehouse is nothing more than a place where a lot of big data is stored. A government has tons of data warehousing. Okay. Dirty data, that's data records with errors. Data scrubbing means that you clean them. So for example, if you're going to do a conversion from one system to another, like when I worked for Siemens, and we would be converting a patient information system from another vendor to us, we had to go into each file, and we had to then do a conversion, like patient name on system A equals patient name on system B, and were the file lengths the same? Was it first name, last name, middle initial? Was it first name? Were they separate? Were they individual? Like, a big problem was that name a lot of times would be one field where it would be last name, first name, and an initial. And nobody wants data like that now. Now they want the first name to be a field, the last name to be a field, and then the initial to be a field. Okay, so data scrubbing is cleaning up those dirty areas. Object-oriented databases store objects, and I explained that before. Pictures, audio, movies. Okay. And multidimensional, which is really where we're going, and we think about augmented reality here, stores in multiple dimensions. It's stored in cubes, if you can imagine that. Pretty soon we're going to be able to store smells. That's going to be pretty amazing. So intelligent searches using natural language, as I talked about before, where I can just say, how do I do animation in PowerPoint? Okay, so dealing with databases, you can read this yourself. Think about how you'll get the information. Personal data, all about you. So as we all know, identity theft is really big. And actually the biggest area right now for identity theft is your health records. And people want your health records because A, your health records don't change, and B, it's a great way to be able to go and do get drugs. So identity theft is a huge thing. There's a whole industry in preserving people, protecting people about identity theft. Record matching uses a unique field to combine information from different databases. What do you have to have? You have to have a common key. Okay, privacy is decreasing. Data can be transmitted almost instantly. Workplace monitoring, surveillance cameras. These are ways to help us. But the fact of the matter is that as we put more information about ourselves out there, it is just easier to have our privacy violated. Okay, so here's some information about Code of Information Practices, Patriot Act. There is a current controversy with the iPhone and the way it is protects information. There's an article in our module this week that I'd like you to look at. Okay. Summary, there are specialized databases, libraries, and the trend is away from large centralized accessibility to data the trend is away from the large centralized database, accessible only to data processing. So the process, what this sentence is saying is there's a trend that users get their own data. Why didn't they just say that? All right, privacy. And that's it. So I hope you've enjoyed this presentation. I hope if you have any questions, let me know. This is one of my favorite topics. But remember, database is a software, and you need to have unique keys to be able to combine database between different tables. Bye-bye. Have a great rest of your time through this module.